Okay, let's have a look at the last question in this paper. So this is a projectile question, but let's have a look. So the points A and B lie 50 meters apart on horizontal ground. At time t equal to 0, two small balls P and Q are projected in the vertical plane containing A, B. And then ball P is projected from A with speed 20 meters per second at 30 degrees to AB. So we can first resolve particle P, one horizontal, one vertical. So the vertical should be 20 sine 30, and the horizontal will be 20 cos 30. And then ball Q is projected from B with speed u meter per second at an angle theta to BA, as shown in figure 3. So again, we can resolve this one as well. So one vertical, one horizontal. So vertical would be u sine theta because it's opposite, and then horizontal would be u cos theta because it's adjacent. And then at time t equal to 2 seconds, P and Q collide. Until they collide, the balls are modeled as particles moving freely under gravity. And in part A, find the velocity of P at the instant before it collides with Q. Okay, so we want to find the velocity of P when it collides, before it collides with Q. So if we only need to look at particle P, and we're looking for the velocity of P at time t equal to 2 seconds because that's when P and Q collide. Yeah. So first, horizontal direction, we know u is just equal to 20 cos 30. So horizontal direction, the velocity never change. It's constant, so just stay the same. So we just have to work out the vertical velocity. So for the vertical component, we know the initial velocity is 20 sine 30. And because this goes up, it's against gravity. So A is equal to negative g. And we know t is equal to 2 seconds. So we can just use v is equal to u plus at. So we know u is 20 sine 30. And then A is negative g, which is negative 9.8, and time t is equal to 2. So put that in the calculator, 20 times sine 30 minus 9.8 times 2, that will give us negative 9.6 meter per second. So, because there's 6 marks, so you can't just leave like that. Yeah, although we have the horizontal component and the vertical component at time t equal to 2. Yeah. So because there's 6 marks, so we have to work out the speed and the angle, the direction. Yeah. So first we draw them out. 20 cos 30, we can actually work out the number. So 20 times 5 cos 30 is 10 root 3 meter per second horizontal. So it should be 10 root 3 to the right hand side. And then negative 9.6, because originally we used positive as the upwards as a positive direction. This time we have negative, so it has to be goes down 9.6 meter per second. So like this. So that means speed has to be the magnitude of this, and the angle, this angle is what we're looking for. So first we work out the speed, so we can just do square root of 10 root 3 square plus 9.6 square. So that should give us 19.8 meter per second. And then the angle theta should be, so 9.6 is the opposite and 10 root 3 is the adjacent, so it should be tan. So tan inverse of opposite over adjacent, 9.6 over 10 root 3. Then that will equal to, so tan inverse 9.6 over 10 root 3. That's 28.997. So we can round it to 29 degrees. So now we can say the velocity of P at the instant before it collide with Q would be, so speed 19.8 meter per second at an angle of 29 degree below the horizontal. Because this one goes down. Yeah. So if it goes up, we should say above the horizontal. Okay, and then part B. So part B, they want us to work out the size of angle theta and then the value of u. So now we need to use both particles P and Q. So let's have a look at what information we know. So for particle P, we know ux is equal to 20 cos 30, which you already know is 10 root 3. And then the vertical component, the initial velocity uy, is equal to 20 times by sine 30. So that should just be 10 meter per second if we put in the calculator. And the acceleration is negative 9.8 meter per second square. And we don't know what's the horizontal displacement, and we don't know what's the vertical displacement. And then the velocity we do know. So Vx is still the same because horizontal never change, and then Vy is negative 9.6. Okay. From here, we can work out and time we already know is 2. At time t equal to 2 seconds, P and Q collide. So we can work out the vertical and the horizontal straight away. So for the horizontal, we can just use velocity times time. So 10 root 3 times by 2, then that'll be 20 root 3. If we want to change it into decimal, that should be 34.64 meters. And then for the vertical displacement, because we know U, we know V, we know A, we know T, you can use any formula. S equal to UT plus half AT square, or V square equal to U square plus 2AS, both works. I will just use S equal to UT plus half AT square. So U is 10 times T, which is 2, and then plus half times by A, which is negative 9.8, and then T, which is 2, and then square. So put in the calculator, we have 20 plus half times negative 9.8 times by 2 square 4. So we have 0.4 meters. Okay. So now we work out let me just double check. It seems too small. So 10 times 2 plus half times negative 9.8 times by 2 square. Yeah, it is 0.4. Okay. So now we work out the horizontal component, the displacement, and the vertical displacement. So we know it has to go something like this, and this will go something like that. And then the horizontal displacement for P should be at this position. So that would be 34.64 meters. And then the vertical component is 0.4 meters. So that means for the particle Q, because the total distance between A and B is 50. So if P travels 34.64 meters, that means Q has to be 50 minus 34.64. So 50 minus 34.64 is equal to 15.36. And then they should have the same vertical height because that's where they collide. They have to have the same vertical level. Yeah. So which means for particle Q, we know the initial horizontal, that would be U cos theta. And then the initial vertical would be U sine theta. And the acceleration is negative 9.8 meter per second square. And then the horizontal displacement we know is 15.36 meters. And then the vertical displacement is equal to 0.4 meters. And then the final velocity for V, we don't know. but we know t is equal to 2. So that's all the information we know, and I think should be enough to work it out because we can set up two equations. So for the horizontal, we can use u cos theta times by time 2 is equal to 15.36. And then for the vertical component, so we need to use the initial velocity, and then we know acceleration, and then we know time t, and then we know s. So we can just, again, use s equal to ut plus half at squared. So s is 0.4, and then u, which is u sine theta in the vertical direction, times by t, which is 2, and then plus half times by a, negative 9.8, times by t squared. So that'll be the two equations we have. So we can now simplify and try to solve it. So for the first equation, if we simplify, we have u cos theta is equal to 15.36 divided by 2 is 7.68. And then for the second equation, so we can try to make u sine theta as the subject. So then if you have u sine theta, u cos theta, you can try to make into tan. Yeah, that's what we want. So rearrange this one, we have 0.4 equal to 2 times by u sine theta. And then this will be minus. So 0.5 times 9.8 times by 2 squared, 4. So that should be minus 19.6. So then 0.4 plus 19.6 is equal to 20. So 20 is equal to 2u sine theta. Then divide by 2, so 10 equal to u sine theta. So we have our second equation. U sine theta is equal to 10. Okay. Now we have sine and cos. And then, so u sine theta, u cos theta. So if we use u sine theta divided by u cos theta, so that should give us 10. So u sine theta over u cos theta is equal to 10 divided by 7.68. So u over u cancels out. Then we have tan theta is equal to 10 over 7.68. So theta should be just tan inverse of 10 over 7.68. So put in the calculator, tan inverse of 10 over 7.68 is equal to 52.4757. So we can round it, so 52.5 degree. And then to work out u, we can just substitute back into any one of them. So I will substitute into u sine theta to 10. So u sine theta equal to 10, that means u is equal to 10 divided by sine theta, which is sine 52.5 degree. So put in the calculator, 10 over sine 52.5 degree, that'll be 12.6 meter per second. Then that will be the answer. Okay, part C. State one limitation of the model other than air resistance that could affect the accuracy of your answers. So you just say what we said before. So you can say like G is not exactly 9.8. You know, we need a more accurate value of G. So G is not exactly 9.8 meter per second square. Now you can say like, because it's a model as particles, you can say P and Q, the balls have dimensions. Yeah. Or you can say the spin of the ball. Yeah, both works. So you can say any of this. Yeah, it's only one mark. You just need to say one of them.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.